Hello everybody, the purpose of today's video will be to configure iOS-based IPS and then doing some penetration testing with Kali Linux and Metasploit. Let's have a look at our topology for today. You'll notice we have two internal zones. This zone here will be where our attack will be originating from. I know normally in real life scenarios you would see an attack originating from the internet, but for simplicity's sake and just for this mock-up, we'll be doing it from this DMZ network. The configuration steps are the same and the end result is exactly the same. This network here will be for our internal host, which will be running CCP, Cisco Configuration Professional. We will be using CCP to configure the IPS sensor and definitions. You can do this also from the command line interface, but if any of you are studying for any exam certifications in security, CCP is a requirement, so we'll just stick with that. There are a couple requirements that we'll need before we can proceed with configuring the router. Firstly, you'll need a iOS image with IPS functionality. I'm using a 7200 series image, advanced IP services. Once you have that, you'll want to go over to the Cisco download page and you'll want to download Cisco Configuration Professional. I'm currently using 2.7 for my purposes. Then you'll also want to download the signature packages that are compatible with your iOS image. My signature package that I'm using is the S456-CLI package. And lastly, you'll need the Cisco public key, which iOS uses to access the signature packages, which is right here. If you Google that, you'll be able to find it easily. Once you have CCP installed, you'll also want to edit your Java security, add some exceptions, most important one being the bottom one, and then some local host information. And after you have all that, we should be ready to go with the base configuration of our router. Now that we have those items out of the way, we can proceed with putting a base config on our IPS router. First, we'll configure the interfaces. We'll do the external interface with DHCP so it can connect to the internet, as well as the internal private interface, specify its NAT inside for the PAT portion, and then as well as my DMZ interface right here. Then we're going to do an access list for the PAT overload section, as well as set up the PAT overload for the Kali host, configure DHCP for our CCP host in our private network, set up a default route to the internet for the Kali host. Here we're doing a base configuration to allow Cisco Configuration Professional to connect. You just want to make sure you have a couple switches in there, namely login local. You want to set the transports for the VTY. You want to make sure you have these two, the HTTPS protocol and blank HTTP protocol for CCP, depending on what you want to use, as well as set a username and secret for your CCP user. Okay, so now that we have that out of the way, we can continue on with the configuration of IPS. For this portion, we'll be using our CCP host, located right here. Let me bring them into the screen. So, just to recap, our CCP host is sitting right here, and it's a Windows XP machine running Cisco Configuration Professional. First thing you want to do is under Manage Devices. Here, I'll walk you through from the beginning. You'll be presented with this, splash page at the beginning once you launch CCP. You'll want to click Manage Devices, put the IP address of your router in. As you can see here, it's the 10.1.1 network, and we have the .1 here for the FA0/1. And then we'll put our username and password, which we specified earlier, which is admin and password 123. If you specify Cisco here, it will think it's a default password and force you to change it. You can check this box here when you're done. Normally you'd want to always connect securely, but for, again, simplicity's sake and also to speed things up, we'll do plain HTTP. Press OK, and you'll see discovery status discovering. Under discovery details, you can see it's starting to pull some iOS information, hardware platform, etc. We'll let that run its course, and then we'll proceed with configuring IPS. Alright, so now that we have our device discovered, we can go over here. If you have multiple devices in CCP in your community, you can select it here, and then you'll want to click on the configure button. You'll want to click on security, and you'll want to click on intrusion prevention. This may take a second to load, and you'll want to click on launch IPS wizard. So the SDEE notification basically stands for Security Device Event Exchange Protocol, I believe. It's a TCP protocol. It basically is used to communicate IPS events and information to IPS managers like Cisco Security Manager or IPS Manager Express or CCP, etc. So you can just click OK. You might see this a couple times. That's fine. You'll want to hit next here. It will just give you a couple of the items it's going to be going through. So first we want to select our interface. So according to our topology, we have we're going to be filtering on fast Ethernet 1/0, and we'll be filtering inbound. So let's go ahead and select that 1/0 inbound. Now it'll ask you for a signature file and public key. So for the signature file, you'll want to, the way that I'm going to be setting it up will be with a TFTP server. So on this actual VM that's tied into GNS3, I have a simple TFTP software, and in there I've specified a directory with my signature packages as well as my public key. So we'll be using that. We will go TFTP, and we'll do the IP address of our config machine, 10.1.1.51, and then you'll want to specify the package that you want. So for me, I'm using the S456. Hit OK here. Then you'll want to get into the public key information. So for that, you'll want to open up the public key. You'll want to select the name of the public key. Put that in here. Then anything under key string, except for obviously quit, exit, exit. Put that in here. Next, config location. There's a couple of ways you can do this. I've done it with a local storage on the router itself before by going here under memories and slots and specifying some space here, then formatting the disk. But for simplicity's sake, we will do it in the TFTP server. So again, and usually you'll want to select a secure protocol in production, not TFTP. You'll want to select SCP or HTTPS, but again, for simplicity's sake, we'll just go with TFTP 51, and the folder I think I have is IPS 5. Okay, here's the category of signatures. So if you select advanced, it will load a large amount of signatures into memory, and given the fact that we're limited resources here in our virtualization mockup, we'll just select the basic category, and then we'll go ahead and manually unretire and enable the signatures that we need for this specific penetration testing, and I'll explain those terms a little later, unretire, etc. So we'll select basic, next, finish. We will deliver the commands to the device. These are the commands that you would do if you're doing this using the command line interface instead of the CCP. So let's deliver that. Once that's delivered, it will begin to pull the signature from our TFTP server here, and this may take a while, so I'll pause and we'll come back when we're ready to go. This is the interface that you'll be greeted with once that's finished. Before we proceed, a couple of things I wanted to touch upon pertaining to IPS in specific. Firstly, if you remember earlier when I configured the config location for IPS, this is because the IPS configuration is not stored in the running config. That would be way too much data and way too much information to put in the running config, so it's stored in a separate location, and that's the reason why we configure that in the wizard. Then there are some other terms that we should touch on briefly under SEAP configuration. Those terms are the severity of an attack is calculated by what's known as a risk rating. The formula for that is severity plus fidelity, severity times fidelity times TVR divided by 10,000. So these two items here, severity and fidelity, those are hard-coded in each signature and cannot be changed. The severity is how much of an impact that certain type of attack will have on your network, and the fidelity is how likely a match of the signature is to be an actual attack. Those are tied, and they all contribute to the risk rating overall. The TVR, however, target value rating, is not tied. This is something that we can use. It's a mechanism that we can use to influence the triggering of actions in the event of an attack. It's essentially just a weight that you can assign to each signature or overall to the IPS sensor, that you can, for example, you can specify a subnet to be mission critical. Let's say your servers are in a specific subnet. You can specify that subnet to be mission critical, and therefore any attacks that are towards that subnet or any of the hosts in that subnet would immediately have a higher risk rating because you specified those as mission critical. Then you have the event action filter, which is a mechanism used to stop countermeasures for valid traffic that shouldn't be generating alarms. And the event action override, which is actually very important as well. You can assign a risk rating to each event action type, so you can manually lower a risk rating for an event action type. An example I have here is, for example, if you want to reset TCP connections, anything that triggers a risk rating of 95 to 100 will automatically reset that connection. I manually specified that. Or I can drop that down to 75 if I really, I'll get more false positives, but, it'll be more secure. So with that in mind, let's get back to configuring the IPS sensor. So once it's done loading the signature into memory and unpacking them, this is the interface that you're greeted with. So you can see here it's enabled on our fast Ethernet 1/0 interface, direction inbound. And the first thing you'll want to do is you'll want to go to the SEAP configuration and set a target value rating. For this, we will do we'll do the interface of the router here in the DMZ to help with our triggering of our definition. So that will be We'll do 172.23.23.1. Okay, we'll apply that. Then what we'll want to do is, let's just do an event action override. We'll do deny, we'll do reset TCP connection for any hit in the risk rating range of 95 to 100. We'll apply those changes. And then what we'll want to do is we'll want to go down to our signatures, which are here at the bottom. Now this may take a while just because there's look at all of these signatures. There's a huge number of signatures. The one that we're looking for is, we'll sort by signature ID, and the one that we're looking for in specific is, I believe, 6009. Let's see here. We'll do 6009. Here we go. So we'll do a SYN flood denial of service. So this one here is already unretired as part of the basic package. Otherwise, you'll want to click that button here, and then you also want to click enable, and then you'll want to apply the changes. Now this may take a while, so I'll just hit pause and we'll come back once it's ready to go. Alright, so now that we have that signature, which was unretired and loaded into memory, now that we have enabled it, there's a couple things I wanted to show you. First, let's go back to that signature here, 6001. Let's take a look at 6009. Let's look at some of the information we get here. So you can see severity is medium, fidelity is kind of low, it's not retired, and it's compiled, which means we've enabled it. Here, so it says it's been enabled. So I wanted to point out, if you right click it and go to actions, you'll see here all it does is produce alert out of the box, which is perfect for our testing. So what we're going to do now is launch an exploit. So I'll bring our exploiting VM over into the view there, and that's sitting right here in this network here. Again, remember our IPS is monitoring this interface right here. So we're going to be using something called Metasploit framework, and we're going to be using a SYN flood for our denial of service attack. So basically what that does is it establishes a bunch of half-open TCP sessions with the router. It initiates the handshake, it gets the SYNAC back from the router, and it just keeps going over and over again, leaving those half-open sessions, keeps hammering the router using up resources. So in order to do that, we're going to go to, we're going to load the exploit. So we're going to go use auxiliary DOS TCP SYN. So the required are the only things that you need to set in order for it to launch. So we're going to do the rhost, and that will be the interface here, which is 172.23.23.1. You can even spoof the source if you want. I guess we'll do that. We'll do 172.23.23. Whatever, 247. An address that's definitely not mine. Now what I want to do is it's actually kind of neat to watch it cross the wire here. So we'll bring that up, see if we can fit it all into one view. So we have our Wireshark running here. I'm not sure if we can squeeze it all in together or not. And we'll bring over our, and I just want to show you also the console of the router. Just for kind of a benchmark here, we'll do a show process CPU. We'll include 5. So we'll see processor is pretty low. It's hovering around 5%. And we'll see what happens once we start launching our attack. So let's bring that over here. Let's launch this attack. Watch it come across the wire here. You can see all the sins here coming in, literally hundreds of them all incremented up. And you can see the signature is launching, but all it's doing is the only event action it's taking is producing an alert. So if we show the CPU, we'll see it start, pegging up to, what is it, as 36, 39, and it's just going to keep rising unless we do something about it. So let's stop this attack over here. We'll see all the sins and the sin axe die down, and we'll open up our CCP. And there's 2 places we can do this. Under actions, we can do it here. I like the deny packet in line. But what we'll do is we'll do it globally. We'll do an event action override. We'll add it. You'll want to make note of, you see here the severity is actually fairly low, and the risk rating overall is 100. So what we'll do is we'll do a we'll just go 75 to 100, deny attacker in line, apply that, and we will see the difference next time we try. This attacker tries and launches the attack. So we'll launch it again. We'll see the sins coming in. We will see the 1 log message here. However, look at that CPU is staying normally low because the attacker has been completely denied in line, and it refused from any further connections. So I mean, that's actually pretty cool, I think. Alright, so that is more or less everything that I wanted to cover. We'll stop this attack here. And I guess the last thing I wanted to touch upon is your IPS security measures are only going to be as good and as accurate and effective as the validity of your source IP address. So you need to make sure that there's no spoofing taking place. On the inside, you can do stuff like DHCP snooping in conjunction with dynamic ARP inspection and IP source guard to verify the source. Basically, we need to ensure that our layer 2 and layer 3 are not being lied about. Otherwise, our countermeasures, won't do anything because it'll be an ever-evolving source IP address. If the attacker is coming from the outside and spoofing his IP address, you can do something like IP unicast reverse path check on the interface, where the router will turn away any packets from internal interfaces which it knows are on the outside, or something along those lines. So I guess that's the last thing I want to touch upon. And before signing off, all of the GNS3 topology files as well as the config files I'll make available in my blog, which I'll link in the video description. And if you have any questions or any topics that maybe you find confusing, feel free to drop me a note on my blog or send me an email. I'm always willing to help, and I hope that you found this informative. Thank you.